Swara. Today we are discussing about class 12 physics chapter number 2, electrostatic potential and capacitance. In this lecture we will see the summary of these chapters. So please pay attention in these lectures. So we are discussing all these chapters, all these chapters summary. So see here. Now first one is the our second chapter name is that electrostatic potential and the capacitance. So see, first of all, electric potential energy. See here we have to write down the electric potential. So first of all, what is the electric potential energy? Okay, what is the potential? It means the we have a something is that to do the work. So it is electric potential energy in the form of mechanical energy which is conserved. Okay, anytime a charge move within an electric field, work is done on that charge. It is I tells you that potential, it means we have we have ability to do work. So this is the anytime charge move within an electric field, work is done on that charge. So if positive charge move in the direction of the electric field, it will be loss P into E. If a negative charge moves in the direction of electric field, it will be again P into E. Why? The exist of where the electric field lines are parallel and evenly spaced. Okay, there are the parallel lines are there. See here, electric field are parallel lines are there. So direction of field is determined by which way a small positive charge will move. It's free to do so. We will get that the values of that. Now see here, the charge loss electric potential energy as it falls in the uniform electric field. What will happen? A positive, the charge losses electric potential energy as it falls in a uniform electric field. See here, this is our positive charge and this is our negative charge. Now a ball loses gravitational potential energy as its flow falls towards the earth. Positive charge will be goes at the charge loss electric potential energy as it falls in a uniform electric field. Similarly, the ball losses similar as, or the ball loses gravitational potential energy as it falls down the earth. So the compare the charge moving through the uniform electric field and the ball moving through the gravitational field. So see here, hello everyone. So compare a change moving through a uniform electric field and a ball moving through a gravitational field. So see here, the positive charge lost potential electric potential energy, and it falls in the uniform electric field. And also when the ball is lost the gravitational potential energy as it falls toward the earth, so it will be goes to the downwards. So in this is the uniform gravitational field and this is the uniform electric potential fields are there. So see here, electric potential field, it is equals to energy in a uniform electric field, electric potential energy in a uniform electric field. So P potential electric energy is equals to minus Q into E into D. So electric potential energy, it is equals to charge into the electric field strength into the displacement from a reference point in the direction of the field. So this is our basic phenomena is that. Now see here, electric potential energy for a pair of charge. So it is equals to Kc Q1 Q2 upon R. See here, Kc Q1 Q2 upon R. See, this is the energies can be added together using algebraic summation. These are the scalar quantities. Now see here, in this second topic is that potential difference. Okay, what is the potential difference? So first of all, electric potential difference is change in electric potential, a change in the ability to do work. So potential energy divided delta V is equals to potential energy divided by the Q. So the change in ability to do work, it means the potential energy difference is change in a electric potential, change in ability to do work. It means there are the work on the charge, how much work on the done on the charge particles we need to do there's that much energy. This is known as the delta V. It is a potential difference. Okay, we know about that there are the two drums are there. One drum have a full fill of water and another is a half fill of the water. On that time what will happen, if we are connecting to together, on that time what will happen, the full fill drum will be waters will be trying to go to the balance of both the drums. So this is phenomena is known as the potential difference. So it means there are the there are the water water difference, water level difference are there. Similarly here what will happen, there are the charge difference are there. So charge difference, if we are trying to compare, or if we are if it is trying to balance this phenomena, on the time what will happen, on the time the charge will be trying to balancing to each other on the, this phenomena is known as the potential difference. So this is the change in the electric potential. It means it will be trying to change in electric potential. So this is the basic phenomena is that. So delta V it is equals to P into E electric field upon Q. So as a unit of as a unit is volt, or it is equals to joule per coulomb. Okay, it is equals to joule per coulomb. Now 1 coulomb charge moves through a potential difference of 1 volt. The charge loses 1 joule of energy if the electric potential electric energy is 1 joule and the charge is 1 coulomb. So on the time what will happen, we get the 1 volt values are there. Now for example, the battery is the difference between two terminal on a battery's range from 1.5 volt to 12 volt. As charge move from one terminal to another, the energy can be used for work like water falling over water miles is used to do work. Okay, water falling mile the mile. So household electric outlet is 120 volts. So see here our battery is the difference are there. So what will happen, there are the higher positions are there, it will be goes down to lower positions. So it and trying to balancing the phenomena. See here also is there, what will happen, upper limits are there and there are the lower limits. So when we are trying to balancing to each other, on that time it will be goes to higher level to lower level. So the difference is that what will happen, like a water falling over a water miles is used to do work. Okay, so this is our basic phenomena is that. Now potential difference in a uniform electric field, what will happen, the delta V it is equals to minus E into delta D. Now delta D is the displacement in the direction of electric field perpendicular to movement in an electric field, does not change the electric potential difference. Why is there is a negative sign is here, remember the equation of E, it's from in the equations chapter number 1, sorry here I written as 17. So chapter number 1, it is equals to Kc into Q1 upon R square. We know about that the K Q1 upon R square. K it is our proportionality constants are there. So from this equation we know that the negative signs are there. So potential difference between a point at an infinite point near a point charge doesn't straight over this too much. Look at the explanation of, sorry, don't stress over this too much work. Look at the explanation on the next chapters. Delta V it is equals to Kc in Kc into Q divided by the R. So see here, now vector in a electric potentials. Electric potential are a vector quantity? No, these are the scalar quantity. Simply added the electric potential, the paying the attention to the sign to get the algebraic sums. Okay, simply add the electric potentials, paying attention to the sign to get the algebraic sums. This is a no, these are scalar quantities. Okay, this is a not a vector quantity. This is a scalar quantity. Now battery does work to move charge. How it will be work, inside 12 volts battery the electric field does 12 joules of work to move 1 coulomb charge from the minus terminal to plus terminal. When you connect your device to this battery, the charge move from the positive terminal through the device positive terminal through the device towards the negative terminal and gives off the 12 joules of energy to power your device. So it will, what will happen when you connect your device to this battery, the charge move from positive terminal to the negative terminal and gives up to 12 joules of the energy to power your device. Now when it's reached the negative terminal, the charge has an electric potential of 0 against, and the battery does 12 more joules of work on the charge to get it back to the plus terminal, ready for the another round trip through your device. So when it's reached negative terminal, the charge has an electric potential of 0 again, the battery does 12 more joules of work on charge to get it back to the plus terminal, ready for the another round trip through the your device. So this is our electric field, electric potentials. Okay, now in this, now see here, now our third section is that capacitance. So first of all, capacitance, a capacitor and the charge stored. A parallel plate capacitor of two parallel metal plates separated by non-conducting material, then rolled into a cylinder. One plate is attached by conducting wire of to the negative terminal of battery, and another plate is attached to the positive terminal of the battery. So this is known as the capacitors. Now the difference in a potential energy in the battery cause opposite charge to build up on the plates, so that the eventually the potential difference between the plate is equals to the potential difference between the battery terminal. What is that? The difference in potential energy in the battery cause opposite charge to build up on the plate, so the eventually the potential difference between the plates is equals to the potential difference between the battery terminals. So in this way, the capacitor can store charge and the potential energy away from the battery. So the capacitance of conductor is its ability to store energy in the form of electrically separated charge. So C is equals to Q upon delta V. So capacitance it is equals to charge on a plate divided by the potential difference, and its SI unit of for capacitance is the Faraday. So coulomb, it is equals to coulombs per watt. Now typical value range from 1 microfarad to 1 picofarads are there. Now capacitance for a parallel plate capacitors in vacuum. So in the whenever we already study in the previous lectures are there, so please refer the previous lectures, and after that you will revise this phenomena. So capacitor or for a parallel plate capacitor in a vacuum, so C it is equals to epsilon 0 A into D. So capacitance is equals to permittivity of vacuum multiplied by the area of one plate divided the distance between the plates. So C is equals to epsilon 0 A into D whenever the capacitor for a parallel plate capacitors in a vacuum. So capacitor for a sphere increase with the its radius. For example, earth has an extremely large capacitance, so it can provide to accept large amount of charge without its electric potential changing very much. So this is why the earth is used as a ground in electric circuits. Now the material between the plate of capacitor can change its capacitance. What is that material called? The dielectric is used to improve capacitance. It means there are the dielectric material are used to improve the capacitance. So see here, the material between the plates of capacitor can change its capacitance. So a dielectric material, it means there are the some materials are put between the two plates. So it is an insulator, look like a rubber, glass and mica. It is C that is the inserted between the plates of a capacitor. Also Teflon, bakelite, those are the dielectric materials are there. So capacitor which allows the charge to accumulate on the surface of the plate. A vacuum can't do this. So this allows the capacitor to store more charge for a given potential difference, increasing the conductor's capacitance. Now discharging capacitors rapidly release the charge. So once the capacitor is charged, the battery can be removed from the circuit and the capacitor will be remain charged as long as is to not connected to a conductor. Once the plates are connected to the conductor, the capacitor will discharge. The charge move back from the one plate to another until there is a zero potential difference between them. So this allows an instant release of the energy stored in the capacitor, which has many applications, camera, flash for examples. Okay, so what will happen once the capacitor is charged, the battery can be removed from the circuit and the capacitor will remain charged as long as is not connected to a conductor. Once the plate are connected to a conductor, the capacitor will be discharged. The charge move back from one plate to other until there is a potential differences between them. So this allows an instant release of the energy stored in the capacitor, which has many applications. First, look like a camera flash. For example, it is a storage capacitors. Now also the potential energy store can be manipulated by bringing the plates closer to each other, which can be detected some types of keyboards using this. So potential energy store can be manipulated by bringing the plates closer to each other, which can be detected some type of keyboards use this. So finally, since the area of the plate and the distance between them can be control the capacitance, and thus the electric field strength can also be easily controlled. So this is our capacitors use. Now energy and capacitor. A capacitor store electric potential energy because it's require work to move charge through a circuit to opposite plate of a capacitor. So the work done is measure of a transfer energy. What is the capacitor store electric potential energy? Because it's require work to move charge through a circuit to opposite plate of a circuit capacitor. So the work done is a measure of the transfer of energy. So see here the potential energy, electric potential energy in a joule. P is equals to 1 half Q into delta V. In a charge, it is equals to C into delta Q is equals to C by C into V. So V C it is equals P it is equals to C 1 half C into delta V square. So and also C it is equals to Q square upon 2C. So we can write down in these three different types these equations. So P is the electric potential energy in a joule, Q it is equals to charge on one plate in a coulombs. Now delta V is change in potential difference in volt, and the C is our capacitance of the conductor in a coulombs. So see here, this is our basic things are there of these chapters. So thank you guys, thank you. If any kind of problem, if any kind of doubt in these chapters, then you can comment in the comment box. Thank you guys, thank you so much.